Hello everyone. In this session, we will learn about the modulus of a complex number. It's a very important concept in the context of both your class 11, 12 as well as the entrance exams. So let's see what is the modulus of a complex number. Yeah, so the standard form of a complex number is a plus ib. We denote it by the letter z. Z is equals to a plus ib. We can also write this in the form of an ordered pair A, comma B. Now, we need to consider a complex plane. A plane where we represent the complex numbers is called as a complex plane or an argand plane. So, let us consider a complex plane. So, where in coordinate plane we have x-axis and y-axis, whereas we know here a plus ib is a standard form of a complex number. A is called as the real term and b is called as the imaginary term. So, in coordinate axis or in coordinate plane, we talk about x-axis and y-axis, but here we write this as real axis and imaginary axis. So a plane where we represent the complex number is called as an argand plane. This plane where we represent a complex number is called an argand plane. You can also call this in simple terms as a complex plane. So now we are discussing about the modulus of a complex number. So we know we can mark the complex number in the plane a comma b is our complex number. So this distance on real axis is a and the distance on imaginary axis is b. Let us consider a perpendicular from origin to the complex number. The distance from origin to the complex number is called as the modulus of the complex number. The distance from origin to the complex number is called as the modulus of the complex number, and we denote this as r. So distance from origin to the complex number is called as the modulus of the complex number, and we denote it as r. R is equals to mod z, or the modulus of a complex number. Now to find the value of this mod z, we need to draw a perpendicular from the complex number onto the real axis, so that a right angle triangle is formed. So this we know is the value on the real part is a, the value, the distance on the imaginary part is b. So this is a right angle triangle. Now in order to find the value of r, remember r is the slopey side, the hypotenuse, the highest side is called as the longest side, or the slopey side is called as the hypotenuse. So if we consider this as a right angle triangle, this is a perpendicular, so this will be clearly 90 degrees. So this is a right angle triangle. By Pythagoras theorem, we can write by Pythagoras theorem, hypotenuse square is equals to opposite square plus adjacent square is actually the definition of Pythagoras theorem. Or you can also say square of one side is equal to sum of the squares of the other side. So we can write r square is equals to a square plus b square, sum of the squares of the other two sides. The other two sides are a and b, so a square plus b square, this is the model, the hypotenuse value is r. So we can write r is equals to under root of a square plus b square. Therefore, modulus of z is nothing but r, that is equals to under root of a square plus b square. Remember, a is nothing but the real term, so we can write the real term whole square plus the imaginary term whole square under root is the modulus of a complex number. So By definition, what is a modulus? Modulus of a complex number is nothing but the distance from origin to the complex number. The distance from origin, the distance from origin to the complex number is called the modulus of a complex number. Distance from origin to the complex number z or a comma b is the modulus of the complex number. So this modulus can also be called as the absolute value. Modulus of a complex number is also called as the absolute value of a complex number. So whether we write absolute value or modulus of z, that will be z equals to under root of a square plus b square, where a is the real part and b is the imaginary part of a complex number. So absolute value or modulus of z should be mod z equals to under root of a square plus b square, which we can remember this as under root of real term whole square plus imaginary term whole square. Remember, a is the real term or real part and b is the imaginary term or imaginary part of the complex number z equals to a plus ib.